This lesson is for Advanced Algebra, Lesson 2.2 on inverse variation. When students are working with inverse variation, it's important that they remember that an inverse situation has one quantity increasing while the other is decreasing. One's going up while the other's going down. In equation form, the variables will be on opposite sides of the equation, and the x will be underneath the constant. The wording will be y varies inversely as x, or y is inversely proportional to x. So students need to watch out for that word inversely and what that means for where the x value is going to go. K is still referred to as our constant. In a practical way, students should take their cell phone and play their favorite song and hold it at a distance away from them so that their arm is straight out in front of them. As they slowly move the cell phone closer and closer to their ear, the distance away is decreasing while the sound intensity is increasing. That's an example of an inverse situation. The distance decreases while the sound increases. And so here's a quick example of the equation that would be used to describe that. One thing I want to point out to students is that they need to watch out for fractions when they're working with variation equations. Sometimes fractions can mimic inverse situations that are indeed not. So as you look at this first equation, it looks like it could potentially be an inverse situation because there is a fraction here. But if you look at the relationship between the fraction and the number, the fraction and the variable, you can see that they are simply being multiplied together. X is not underneath the fraction, it is simply next to it. So this indeed is a direct situation. So don't assume that the presence of a fraction automatically means that it's inverse. Similarly here, we have a variable and we have division going on, but the variable is not the thing that's being divided. So this is also a direct situation, which can oftentimes be misconstrued or misidentified as inverse. The only one of these three which is, in fact, an inverse situation is the last one. This one is inverse because the x value is on the bottom of the fraction and is being divided. So students just need to watch out for those situations. I don't want students to get tricked unnecessarily. We're going to do a word problem to begin today because the word problems tend to be more difficult for students to handle. So I want to make sure we spend as much time doing those as we do other problems. This particular example involves a seesaw or a teeter-totter, which is commonly found on playgrounds at schools. If students are unfamiliar with that, they can look that up online. This particular seesaw or teeter-totter question does come out of the book and is referred to quite often in the homework. So I want students to be comfortable with this situation. On a seesaw or a teeter-totter, the distance d away from the pivot point is inversely proportional to the weight W of the person sitting on it. Ashley and Sam are trying to balance each other as they sit on the teeter-totter or the seesaw. Suppose Sam weighs 42 kilograms and is sitting 2 meters away. Ashley weighs 32 kilograms. How far away should she sit from the pivot point so that she can balance Sam? So I went ahead and drew a quick, crude picture of the seesaw here with the pivot point in the middle. Sam and his weight are listed along with his distance away. Ashley and her weight is listed. We don't know her distance away. First thing we should do is review the 4 steps from yesterday. There's typically 4 steps involved with variation functions. You want to write the general equation first using all letters. Don't forget the k. Then substitute in 2 values that you know to solve for k. Substitute the k in to complete the function, and then plug in any other missing values to solve. Those are the same steps as we did yesterday in the direct variation lesson for 2.1, excuse me. So we're going to go ahead and do our first step. We're going to copy this statement here and turn it into symbols. Distance away is inversely proportional to the weight. So that simply means distance away is inverse to the W. So the W needs to be on the bottom of the fraction. Notice that the K value is not mentioned in the equation. That is something students will simply have to remember on their own. The next thing we're going to do is try to plug in a D and a W that we know. And for that, we're going to use these numbers here. We know Sam's weight and his distance, so those two pieces are tied together, so we're going to substitute those in. The weight should go in for W, and the D should be your distance. So now we're going to solve that for K. On both sides, we would multiply by 42, and so K ends up being 84. The next step is to substitute that 84 into your original equation. So 84 over W. Last step is to fill in Ashley's information and calculate. Ashley weighs 32, so we're going to fill in 32 for the W, and then we're going to divide. And when you divide there, you get approximately 2.6. This is a distance. We're measuring distances in meters, so we put an M there. As always, students should pay attention to what the question asks you to round to. If they don't specify, you can round to whatever you choose. And the answer that we got makes sense. Sam weighs more than her, so she should sit further away from the pivot point in order to equally balance him. Let's try one more question. This one is not a word problem, it's simply using the words that are given. Suppose y varies inversely as the third power of x. So we know that y equals, since it's inverse, we have to put our x on the bottom. They tell us to use a third power, so I'm going to put a 3 with my x. Now I'm going to plug in the first two numbers that they give me. Y is 10 when x is 4. Let's figure out what the k value would be. 10 equals k over 4 cubed. 4 cubed is 64. 4 times 4 times 4. When I multiply both sides by 4 cubed, or 64, I get 640 for k. I'm going to go ahead and plug that in now. Take that number and plug it in for k. So I get y equals 640 over x cubed. Common mistake here is for kids to drop the cube by mistake. Make sure you're always referring back to the beginning of your problem. Last step now is to find the y value when x equals 2. So we use our 640, plug in a 2 for x. Make sure you cube it first. 2 cubed is 8. 640 divided by 8 is 80. Make sure when you're dividing that you do the top number divided by the bottom. There's one final piece that I want to mention to students. There is intensity of light question mentioned in the homework. It's also mentioned in example 3 in the book. So I'd recommend that students read through page 82 and utilize this equation to help them answer any intensity of light questions.